To the second lecture on 5G communication course. In today's lecture, we will be talking about the most critical application that's expected to be delivered by 5G technology. This application is related to Internet of Things, and this is not any type of Internet of Things. It's what we call massive Internet of Things and the critical Internet of Things, or sometimes we name them massive Internet of Things as massive machine type communication, where you have thousands of devices communicating with each other or with the base station. And the critical Internet of Things, we refer to it as ultra reliable low latency communication, where you have devices that need extremely ultra reliable link with low probability of error and low latency, like less than 1 millisecond if it's possible. So as the Internet of Things emerged, first it was used extensively by people and still is being used by people. We are the ones who are using it and producing data, picture, text, video, music, scan, whatever. As you can see on the left-hand side here, you have the Internet of People. People are the ones who are producing to the network, contributing, making the Internet. On the other side, we have the Internet of Things. The Internet of Things is allowing not only humans to communicate over the Internet and to produce and contribute, but also sub-objects and any dummy things can be made smart and be connected with the Internet. Whether these things are related to industry or home or city or agriculture or grid or whatever, at the end of the day, you can make them smart and communicate with the Internet. For example, you can produce and design a smart coffee maker by itself. It can make coffee at the time you want, whenever you want, and it can bring it to you in the place you want. You can make smart plug, smart agriculture, smart traffic control, smart air conditioning. How do you do that? You need five main components to build an Internet of Things application. The first one, you need a dummy device or an object that you want to make it smart. Example, chair, table, window, curtain, door locker, whatever. These things are passive. Do they communicate with the Internet? Do you have control over them? Unless you manually come and change them, take over them, you cannot. So this is the first component of the Internet of Things application, an object, dummy, not connected with the Internet. The second one is wireless connectivity. But how can you provide this object with wireless connectivity if you don't allow it first to access the hardware of the electronic components? That's why wireless connectivity with microcontroller processor. You have chip microcontroller that has inputs and outputs. Inputs are connected with sensors. Outputs are connected with actuators that take action. And you have a processing inside the microcontroller. And you have wireless connectivity to talk to the cloud and to the Internet and share information and take action from your phone. So what are the components, the five components? The object, the microcontroller, the wireless, the sensors, the actuators connected with the cloud, so that once you reach the cloud and the Internet, then you can communicate with the device from your phone, from your desktop, from your web browser, whatever. And it can also give you information to your phone, your desktop, your browser. Give you an application. The locker of the, think with me, if we want to make the locker of the door smart, what would we do? We want to make it smart. Smart means I can open it from my mobile phone. If I am at work and my son reaches home, he doesn't have key, what do you need to do in the old-fashioned way? He has to come to you to take the key, you need to go there, or you need to go to the home and open the door for your son to enter or whatever. It's a problematic. But what if I don't need keys anymore? If I can open the door remotely from my phone. Imagine, I don't need keys, you can come anytime, and you can just call your father, call your mother, wherever they are, they can open the door for you. So what do you need to do that? What do you need? Basically, the locker is the object. You need to then buy ESP chip microcontroller that has microprocessing capability, computational capability, input, output, sensors and actuators, and wireless connectivity. And this, the good thing about ESP32 or ESP8862, the good thing about them, they are integrated with wireless inherently. They have Wi-Fi chip. They can be connected with the internet. So all what you need, take this locker, and the one that's responsible for connecting, you connect it with an input to the microcontroller. Yes? And whenever someone opens it or wants to open it, it can automatically send message to the master of the home. And this, by sending confirmation, automatically can opens. So the confirmation has to come from an authentic person. This is an example. The same can be applied anywhere to any object. So accordingly, you have a smart agriculture, smart industry, smart education, smart cities, smart homes, anything that you can make it smart. So basically, you have to imagine with me infinity number of applications, opening infinity number of opportunities for whoever serious to solve real practical problem. You are utilizing technology to help you solve practical problems. But you must, while you are developing your application, you must know who your customer will be, so that you know the requirements. You know the requirements of this, and based on that, you adjust your design based on these things. So the Internet of Things growth started with the emergence of the Internet itself. So basically, around 1990, Internet standardized when? Around 1990, 1991. This is the standardization of the Internet and the emergence and the creation of Python technology as well, Python language programming, 1990, around that date. And then at that time, only PCs were connected to the network. Yes, old PCs, these the old ones like this, but even bigger, bulky ones. And after 10 years, around 2000, we started seeing the laptops. After a few years, like 2005, 2000, we started seeing the tablets and also smartphones. So not only PCs, laptops, tablets, but also mobile phones started becoming connected to the network. So the number of devices are increasing. In 2012 and around this year, we started seeing smart fridge, smart TV, smart electronic appliances, basically. But as you can see, many different appliances and many different electronics are being connected to the internet, and it's going extremely exponential. The use of the Internet of Things, even with key locker here, as you can see, they are integrating it with wireless microcontroller and trying to make it smart. And this applies to home, to transportation, to body, healthcare, buildings, cities, and many other areas. All what you need is to put these 5 components that I told you about together with that object, and you have an Internet of Things application that can solve certain problems. And here you can see and find the different Internet of Things device regions. There are applications that require low data rate, medium data rate, high data rate, number of users, low, high, depends on the requirements. So what are the areas of the Internet of Things where Internet of Things devices can be used? Smart cities, smart homes, utility metering, wearables, fitness, remote sensors, actuators for agriculture, and object tracking for objects that you want to ship from a place to another. You can track them simultaneously. For all of these applications, what are the requirements? One common. You are trying to build such applications. Then this means that there are requirements. There are certain features that these applications have to fulfill. First, power efficiency. We need the battery to be sufficient enough and run for long period of time, let's say 10 years or more. Lower complexity, so that when the complexity reduces, the cost reduces and things become more efficient to deal with the network. And longer range, deeper coverage, especially for tracking. For these requirements to be met, we need to develop new technologies at the physical layer, because the current technology that was designed for 4G was not meant to serve these new Internet of Things application. It was designed to serve your phone. Video, text messaging, Facebook, WhatsApp, these things, but not for these kind of applications. For 5G, we don't have only Internet of Things application, but also we have what we call enhanced mobile broadband, where you have 3D ultra high definition video telepresence, tactile internet, where you touch something here, it simultaneously its effect appears on another like PC located in a country which is extremely far away from you, and you can utilize these kind of application for remote surgery operation, autonomous driving, and real-time gaming, real-time teaching, and many other applications. So virtual reality as well, extended reality, and many other applications that require higher throughput, lower latency, and uniform experience. So as you can see, as the application changes, the requirements change as well. And we have last one, we have the high reliability control, what we call it ultra reliable low latency communication. For this, we have autonomous vehicles, autonomous driving we want to provide. We have also robotics. We have energy smart grid, Internet of Things application designed for this, industrial automation, aviation using UAVs, and medical services. For all these types of application, we require higher reliability, lower latency, and higher availability. So this shows that applications that we are trying to meet and provide by 5G, and even if we cannot provide by 5G, hopefully by 6G. So some of these applications are on the white region, which means that they can be provided with the current technology if we tweak it well in such a way that it meets the needs of these applications. And there are new applications that are beyond what current technologies can suffice. So for these kind of applications, we need to design new technologies, a new algorithm, new techniques, and which is the purpose of this course. Teach you the applications, the new emerging applications, the available technology, tell you what are the applications that don't have solid technology to fulfill its requirements, and then act upon that, try to develop our own technology, which we did in the previous courses with the other students. So if you want to summarize the applications to be covered in 5G standard, then you can put them into three categories. The first category, what we call wide area Internet of Things, or you can sometimes name it as massive machine type communication. The second category, higher reliability control, or what you call ultra reliable low latency communication. And the third category, enhanced mobile broadband. Each category has different requirements than the other categories. This means there is no such single technology that can meet the requirements of all these different categories simultaneously at one time. What does this mean? This means that you need to come up with multiple different technologies, or with cognitive adaptive system that can react, can measure these applications, what the users are using and what the Internet of Things devices are trying to achieve and do, and accordingly you teach your machine, you teach your smart system to act upon these requirements. For example, this Internet of Things device is targeting to localize logistic objects and this and that. Then this requires high reliability, extended coverage, low battery consumption. Then in this case, I would need wide area Internet of Things that requires deeper coverage, lower energy, lower complexity, higher density. If I am targeting enhanced mobile broadband, then I need enhanced capacity where the data rate has to be in gigabit, 10 gigabit per second or even more. And you have to be not only with high data rates and high throughputs, but also with low latency. For higher reliability control, you would need here the goal is not data rate, not throughput. The goal here is reliability, lower bit error rate, lower latency. So as you can see, if you come to this category and you find a technology that can meet these requirements, most probably it will not be able to meet the requirements of this category or this. And the same, when you find something that meets the requirements of this area, most probably it will not be able to meet the requirements of the other areas. So it's adjustable. According to the requirements, you use the technology. Massive Internet of Things and the critical Internet of Things. Massive Internet of Things is this, the wide area Internet of Things. Critical Internet of Things is this, the higher reliability control. For massive Internet of Things, you have smart building. Where do you use it? For smart building, logistics, tracking and fleet management. For smart agriculture, smart metering. These are the areas where you can use it, and these are the requirements. What are the requirements? Low cost, low energy, small data volumes, massive numbers. What about the critical Internet of Things? Where do you need to use it? Remote healthcare. It's really critical for remote healthcare when a doctor is dealing with a patient and giving him a drug remotely, for example, with the assistance of a nurse near the patient. It's not that easy. You must provide extremely ultra reliable communication, very low latency and very high availability. If one link is cut, if one link is down, you have another link to substitute for that. And not only for remote health care, but you can also use it for autonomous driving. Imagine you are moving with a speed of 100 kilometers per hour and there is a delay of 1 second. What will happen? You will make an accident. For example, the network, if the network is not capable of meeting 1 millisecond latency requirements, and you are supposed to make a break here, and instead of making it at time X, you are making it at time X plus 1 millisecond, then you have an accident with this speed. So it's very critical that you reduce the latency for these type of applications. Industrial application and control, smart grid automation, all these require ultra reliable, low latency, and very high availability. So depends on where you are, you have different requirements. If you have different requirements, what's there? You need different technologies. Here in the second, what we will be doing in the class after introducing you to these nice applications, to go and study the technologies of the invariants, different waveforms, different multiple access scheme, different technologies that can achieve these nice requirements to enable these applications. So basically, any generation is application require a new set of features and no technology. That's why we come up with a new generation with 2G, 3G, 4G, 5G, and 6G coming after 5G. Because you have new applications, new use cases, new scenarios you want to meet, but the current technology cannot meet them, cannot make them work in a good, satisfying manner. That's why we are forced as engineers and researchers to come up with new technologies that can meet these requirements. So you must understand the cycle, the connection between the application, its requirement, and the technology. That's why any generation, when I ask you about two things. When I tell you what this generation is all about. First, the application, and then the technology that meets the requirements of that application. Different consideration that you need to keep in mind: the technical one, the commercial, and the ecosystem. The technical are related to coverage, energy efficiency, latency, throughput. Your technique must deal with these parameters. These are the performance metric. If you come up with a technique and you tell me your technique is good, how can I judge it? I just list these four, 5 metrics and say, how good are you in coverage? How good is your technique in efficiency, in latency, in throughput? And I give you score. I come to your other friend who came up with another technology and I score him on the same scale. Whoever achieves the maximum in all the scales, I choose his technology. This is what the standard body does with the companies. All the companies propose. Who works for the companies? You guys and engineers usually. You work there for the company. The company tells you these are the requirements. Please deliver a novel technology. You deliver. The company goes with to the standard with this technology and they say, here is the technology. Everybody fights for his technology. Everybody claims he's the best in his field. But nobody trusts anybody. You just come, let's evaluate your work. Come. They make a group of researchers, 100 researchers, or whatever the number is, and this company claims this. Please verify. They start simulating, analyzing, testing, and they come up with results to the community, to the head of the standardization body. We have these results, 1, 2, 3, 4, 5. They are good this much in this area, this much. What about the other companies? They evaluate them, this. What about the others? This. With whom should we go? Which technology should we choose? Let's say they selected Huawei. Huawei saying this technology, they evaluated it fairly, they found it's striking technology, it satisfies all the requirements, then they select Huawei technology. What happens to Huawei? Since this is standard, all the countries have to use this standard, agree on it, make sure that you can use your technology in any country you are in. They come and say everybody should buy and license the patents produced by Huawei. Huawei becomes very rich. See why they are fighting? They are fighting for something that's really very impactful. That's why there are clashes and fight between US and China about 5G, 6G. We want 6. Yeah, Definitely, it's
Japan is also
exactly whoever controls the technology, whoever can produce technology that can meet the requirements first, can make the others slave for him. Because you have to buy from me, you have to get from me, you have to pay me money for using this technology for the rest of your life. Whether you are a company, a country, and the problem, these countries are representing, these companies are representing countries, so the country becomes slave for that technology. Yes? Who's providing the telecommunication equipment for the company you are dealing with? Tell me. Who's? Ericsson, Huawei, Qualcomm, one of these companies. Do you think these companies that you are taking your internet from, they produce these equipments? No. They take it from the big companies. Now the big companies, nobody knows what they are doing with these devices. Nobody knows. So once you agree to use these devices, you are just follower. Whatever price they say, either we shut down or you agree. Either we shut down, yes, they control your fate, your destiny. So either you build your own and compete and fight and produce and make your own technology, or you become follower. And whatever we say, you just say, okay. Whatever money they ask, you just pay. Whatever and you don't know what they are doing with your network. You don't know. You just run it. You just monitor the softwares. If any problem happens, do let us know. We'll come and pay. You are not allowed to touch it. You understand the issue? You understand the importance of being active and contributor and not consumer? It's the difference between leader and follower. And we have the commercial side where we need to consider the quality of service, the security, the cost, the scalability of the network. And we have the ecosystem where you need to prove that your system can work and coexist with other platforms and ensures the strategic investment in Internet of Things is economically and technologically sustainable in the long run. I mean, you are opening in new areas of work, it must be able to be capable and standing by its own for a long period of time. It's not just a matter of year or two. Global reach and interoperability, which is very important so that you can use the service wherever you travel in the world. We already discussed what massive Internet of Things application. These are the ones I just mentioned in the previous slide, and we mentioned the requirements, very ambitious requirements, long battery life, strong coverage, low cost, scale and density, performance, flexibility, and then we need technologies. And here are the available technologies right now. Most of them, they don't meet all these requirements. For Internet of Things, we have Sigfox technology. Anybody heard about it before? Sigfox is basically a company that provides platform and hardware for you to develop Internet of Things applications that can be bought by customers, mostly in Europe. So you can just search it on Google and see what they are doing. But this is like licensed, or it's not open source. Provides a system that's aimed at providing long-range, low-power and data rate Internet of Things connectivity to a network, to base station. Basically integrates you with the base stations and network of cellular. But you must have a look at it. You have narrowband Internet of Things. This narrowband Internet of Things also, it's like 4G technology, but designed for Internet of Things only. You need to get license from the operator. 5G massive type communication, they considered Internet of Things as well. And you have also LoRa. LoRa, the good thing about LoRa, it's open source. Anybody can establish the base station. You can establish a couple of base stations in Antalya and build a community, you and your friends and the ones who want to develop few applications, and nobody can stop your network. Everybody will be connected to your network. It's like as if you are building a network similar to Turkey. Cell, Turk Telecom, but this only for Internet of Things application. You have your own messaging system, your own applications for your own tracking, and it's really very powerful. One of my students was able to use this LoRa to build an Internet of Things application practical over a distance of more than 3 kilometers. He sends and receives without the use of GPS, cellular, or wireless technology, the mobile technology. You have Wi-Fi Halo. It's similar to Wi-Fi but dedicated to Internet of Things, and you have low power Bluetooth and wireless mesh. All these are different types of technologies that aim to meet the requirements of the previous type of applications. And the trade-off among these different technologies that some of them are good in quality of service but very bad in cost. Some are good in interoperability but they are bad in the other aspects. So as you can see, there is no such a single technology that can be good in all the directions, as you can see. So the goal here, companies are fighting with each other to bring a solution, a unified solution that can be good in all the directions so that they can win the market. So this we already discussed them, where you have different types of Internet of Things application with different requirements to different technologies. And here the different practical applications that these Internet of Things technologies can be used in. And the key requirements, again, on a different scaling with numbers, how much the reliability should be, how much the latency for ultra reliable communication, low latency communication, and both jointly. And here a diagram that simplifies the comparison between these different requirements. For example, when you have an transport and logistic applications, you have this dotted line, dotted like shape. You can see with me here on this curve. Battery life is most critical one, and then coverage, and then reliability. But as you can see, security is not that important. Positioning is important, performance not that important. So if it hits the edge from the top, this means it's very critical, this application, to satisfy this requirement. Smart cities, for smart cities, you have this purple line. It's critical in terms of coverage and reliability and quality of service, but not that critical in battery life and, let's say, performance. Based on the application, your requirements changes, and based on that you need to come up with a different technology. Of course, these are not the only issues to come up with technologies that can meet the requirements. You also have some different issues you need to deal with, like policy and regulation, which are made and set by the government and policymakers. In the old days, you can think of life, this blue box, where wireless was not so important, not participating much to our life. ICT, information communication technology, little. Technology is little. Life is this big. There are many other areas. But nowadays, technology is affecting every aspect of our life. Yes? Mobile phones, web, internet, cloud, wireless, yes? We are depending on it on daily basis. Imagine I cut the internet. It doesn't allow you to access the internet for 1 or 2 weeks. It's it's disastrous, yes? So technology is becoming everything now. Fortunately or unfortunately, the good thing about it, it facilitates and make our life easier, and everything is changing. But also, we are so much dependent on it, yes? So this makes it one of our weaknesses. Without it, how can we live? How can we survive? So the IoT transformation, dramatic transformation from isolated dummy system to smart Internet of Things system, driven by the convergence of increasingly connected devices, computing and data economics, and wireless, cloud and big data analytics. All these technologies, they helped in a way or another in the emergence of the Internet of Things application. Unprecedented opportunities for public and private sectors, the ones who are serious to build their own business. You develop new services, new innovative user experience, enhance productivity and efficiency. Think of anything, any use case, any application. You can come up with a solution from the Internet of Things for that problem if you are creative enough. Improve real-time decision making, solve critical societal problem, and many others. Money topics and sectors, privacy, big data, network security, health, business to business, and industrial. These issues need to be tackled and understood very well and regulated by policymakers. It's also interconnected with many layers, hardware, communication protocol, network topology, application, data storage, and data access. There are many other things to consider when you are developing an ecosystem composed of many Internet of Things applications, where the Internet of Things is touching and affecting every aspect of our life, from education to home to city to agriculture, automation, transportation. So when Internet of Things is implemented and integrated with these services, then you have to consider adopting new policies, new regulations, new standards, so we regulate things, because this will allow the emergence of new issues that we didn't consider in the past, and we need now to tackle them, to deal with them. So there are many other things to consider, but mainly they are related to policy and standards and regulation. This is the Internet of Things, this is the future, and these are the main services that 5G and beyond technologies are targeting to meet and achieve. This is why you are taking this course. And having said this, having understood all these applications and the requirements, what's required from us to do? To understand these things, know the effect of them, know the potential, the infinity number of applications that we can produce to come up with new services to make our life easier, faster, simpler, safer, cheaper, whatever. The concept, sometimes we put it under the word SIFs, cheaper, easier, faster, simpler, and safer. And based on that, if there are such useful applications and we don't have technology to meet the requirements of this application, then as engineers and researchers, we have to build technologies, techniques, methods that can meet these requirements to make our life easier and more convenient, and increase our productivity and efficiency, and ensure prosperity, and make our life like much more productive than it used to be. So with this, we conclude the lecture and meet you in the next lecture. Thank you very much for your attention.